Three marble columns stand in a market square in Pozzuoli, just outside Naples. They've stood there for almost 2,000 years, and carved into them, about 6 or 7 meters up, is a band of small dark holes, hundreds of them packed close together, running around the stone like a tide line. Look closer and you'd see they're not damage. They're bore holes, made by a mollusk called a date mussel, a creature that only drills into rock that's underwater, sitting in the sea, for years at a stretch. These columns are nowhere near the sea. They stand on dry ground, in a plaza, under an open sky. So how does a creature that only lives submerged in seawater end up boring a hole 6 or 7 meters up a column that's standing on land? Here's the part that should stop you. The rock above that band is clean. The rock below it is clean. Only that one section, that one specific height, is riddled with holes. Which means, at some point after these columns were built, the ground they stood on sank. Sank far enough that the sea rose up around them, submerged them to that height, and stayed there, long enough for mussels to move in and drill. And then, at some point after that, the ground came back up. The sea drained away, and the columns were left standing in the open air again, exactly where they started, carrying the scar of everywhere the water had touched. The building never fell. It just sank into the sea, and then it didn't. That's not a metaphor. That happened. And it's not the strangest part of this story, because the ground underneath those columns, underneath the town of Pozzuoli, underneath the western edge of the city of Naples, is doing something like that again, right now, tonight, while you watch this. Not sinking this time. Rising. Slowly, the way your chest rises when you breathe, nothing you'd feel underfoot, nothing that makes the evening news most weeks, but measured, patiently, millimeter by millimeter, by more instruments than almost any other volcano on Earth. Since 2005, the ground under that stretch of Italian coastline has lifted by more than 1.5 meters. 500,000 people live on top of it. Most of them go to work, put their kids to bed, and never think about it at all. And here's the part I want you to sit with before we go any further, because it's the whole reason I went looking into this. You'd think, given how much attention this place gets, given the instruments, given the scientists who've built entire careers watching this one patch of ground, you'd think somebody would be able to tell you simply what's happening underneath it, whether it's serious, whether it's building toward something. They can't. Not with certainty. The ground is rising. That part isn't in dispute. But rising how and rising because of what is a question that two of the most credentialed teams of volcanologists working today have looked at the exact same data and answered differently. That's the story. Not just a volcano. A volcano we can measure down to the millimeter and still can't fully read. The book, well, there isn't really a book this time. What sent me down this particular rabbit hole was a research paper published in 2023 by a volcanologist at University College London named Christopher Kilburn, and a body of monitoring records kept by the Italian Institute that watches this ground more closely than anywhere else on the planet, the INGV. I want to walk you through what they've found because it's not what I expected. I went in assuming this would be a story about a ticking clock. It isn't. It's stranger than that, and in some ways, more unsettling, because it's a story about the limits of watching something closely enough. Let's start with where this ground actually is, because the shape of it matters. West of Naples, the coastline curves into a wide, shallow bowl, a stretch of hills and craters and steaming vents about 12 to 13 kilometers across, called Campi Flegrei. The Phlegreian Fields. The name is old and it means burning fields. People who lived here in antiquity didn't need geologists to tell them something was underneath this ground. The steam told them. The smell of sulfur told them. Roman writers described it as the doorway to the underworld. What they were standing on without knowing the word for it was a caldera. Not a mountain with a crater on top, the shape you picture when someone says volcano. A caldera is closer to the opposite. It's a wide depression in the earth, left behind after a volcano erupts so violently and empties so much material out of the ground beneath it that the roof over that emptied chamber collapses in on itself. Where a mountain used to be, or would have been, there's a bowl instead. Campi Flegrei is that bowl. And underneath it, still, sits whatever's left of the system that carved it out in the first place. It's done this twice, catastrophically, in the deep past. We'll get to both. But first I want to take you back to that plaza with the 3 columns, because that's the piece of this puzzle that's easiest to actually see, and it's the key to understanding everything that comes after. In 1830, a geologist named Charles Lyell put a drawing of those 3 columns on the very first page of a book. The book was called Principles of Geology. It went on to become one of the most influential scientific books of the 19th century. A young naturalist named Charles Darwin carried a copy of it with him on a 5-year voyage around the world, and it shaped how he came to think about time itself. Lyell's argument in that book was radical for its era. The Earth's surface isn't shaped by sudden one-off catastrophes handed down from above. It's shaped by slow, ordinary processes grinding on day after day for spans of time longer than anyone had previously dared to imagine. And of everything Lyell could have put on his cover to make that argument, he chose those 3 columns. Because nothing he could describe in prose made the point as cleanly as those boreholes did. Here was solid stone, a building, something humans had built with their own hands, something meant to last, and the ground underneath it had risen and fallen enough, slowly enough, to leave a tide mark on a temple. Proof, carved into marble, that the ground itself moves on a timescale too slow for any one person to see, start to finish, but not too slow to leave evidence behind. That process has a name. Bradyseism, from the Greek for slow movement. It's the up and down breathing of ground surface caused by pressure changes in whatever lies underneath it. And Campi Flegrei is one of the clearest places on Earth to watch it happen, because it's been doing it on and off for as long as there have been buildings there to keep score. Which brings me to the part of this I have to be honest with you about up front, because it's going to matter for the rest of what I tell you. This ground has a long memory of violence, and what it's doing right now is not new. It's the latest chapter in a pattern that goes back further than anyone standing on that ground today can really hold in their head. I want to take you through that pattern in order because each chapter changes what the next one means. And by the end, I think you'll understand why the scientists who study this place most closely are the ones most reluctant to tell you exactly what's coming. Go back roughly 39,850 years. That figure comes from a precise dating method that measures the decay of radioactive argon in volcanic ash. And it lines up closely with a separate radiocarbon estimate from the same layer, so it's about as solid a date as deep prehistory gets. At that point, this stretch of Italy produced one of the largest explosive eruptions Europe has seen in the last 200,000 years. Geologists call it the Campanian ignimbrite, and it sat near the top of the scale we use to measure eruption size, a scale that runs 0 to 8, where each step up is roughly 10 times more explosive than the one before it. This eruption hit a 7. For comparison, the eruption most people picture when they think the volcano that changed the world, Tambora in Indonesia in 1815, the eruption that darkened skies and froze summers on the other side of the planet, that one was also a 7. This one in Italy was in the same class. Ash from it has been found more than 2,000 kilometers away, out on the Russian plain. It's been traced over 1,000 kilometers south into North Africa. An eruption powerful enough to leave a fingerprint on 2 continents from a hole in the ground west of Naples. Here's where I have to slow down and be careful, because there's a claim attached to this eruption that gets repeated a lot, and it isn't as settled as it sounds. Some researchers have argued that this eruption, combined with a severe cold snap that happened around the same time, helped push Neanderthal populations in the region toward extinction, right as modern humans were expanding into the same territory. It's a genuinely dramatic idea, a single eruption tipping the balance between 2 branches of humanity. But other researchers, using a technique that traces layers of volcanic ash through archaeological sites, have shown that in some regions, the cultural shift associated with that population turnover was already underway before this ash ever fell. And more recent work recalibrating when Neanderthal populations actually disappeared puts that extinction slightly earlier than the eruption itself, meaning, in at least some estimates, the timing runs backwards from what the dramatic version of the story needs it to. Climate modeling of the eruption's aftermath also suggests the worst of the cooling largely missed the parts of Western Europe where Neanderthal populations were most concentrated. I'm not going to tell you which side is right, because nobody currently studying this can tell you that with confidence either. What I can tell you is that this is a live, disputed question among the people who study it, not a solved one. And any version of this story that hands you a tidy cause and effect is skipping past a debate that hasn't actually closed. What isn't in dispute is the second eruption. About 15,000 years ago, Campi Flegrei erupted again, catastrophically, forming a second caldera, the one you'd find on a modern volcanology map if you drew a line around the current danger zone. This eruption produced something called the Neapolitan yellow tuff, a soft, pale volcanic rock that if you've ever walked through parts of historic Naples, you have actually stood inside. Ancient aqueducts, old cisterns, whole tunnels and building foundations carved directly out of this stone. The city didn't just get built near this eruption's aftermath. In a very literal sense, it got built out of it. Two catastrophic eruptions, tens of thousands of years apart, and the caldera they carved out is still there, still doing something right under the city that eventually grew up inside it. Now, fast forward, past both catastrophes, into the range of recorded history, where, for once, we don't have to reconstruct what happened from ash layers and mollusk holes. We have people writing it down as it happened. Late September, 1538. A stretch of flat ground west of Pozzuoli, the kind of ordinary countryside nobody thought twice about, ground people had farmed and walked over for generations. And over the course of about a week, 1 week, that flat ground built itself into a mountain, not a metaphorical mountain, a real one, a cone of ash and rock roughly 130 meters high, rising out of ground that had been level a few days before. It's still there today. They named it Monte Nuovo, the new mountain, because that's exactly what it was. New. Born in living memory, in front of witnesses, which makes it one of the first eruptions in recorded history that large numbers of ordinary people actually watched happen, start to finish, and wrote about afterward. Try to hold that in your head for a second. Somewhere in that week, a farmer or a fisherman or a merchant on his way into Pozzuoli looked at a field he knew, a field he could have described the exact shape of, blindfolded, and watched it stop being a field, watched the ground itself swell, crack, and start throwing rock into the sky, hour after hour, day after day, until where there had been nothing, there was a mountain 130 meters tall. We know the ground swelled before it happened. That part is well documented. There's a detail I've seen repeated that the sea itself pulled back from the shore before the eruption started, a kind of warning tide. But I want to be straight with you. I couldn't run that detail down to a source solid enough to hand you as fact. So I'll leave it exactly where it belongs, which is out. What we can say for certain is this. The ground rose, visibly, before it broke open. And that detail, ground rising before something happens beneath it, is about to become the single most important thread in this entire story. Because it's the thread the ground is still pulling on right now, 500 years later. Monte Nuovo went quiet after that week in 1538, and the caldera it sat inside of went quiet with it. Quiet enough that for the better part of 4 centuries, nobody watching this stretch of coastline had reason to think of it as anything other than settled ground with some interesting hot springs. Then, in 1968, it started rising again. Slowly at first, the kind of movement you'd only catch with an instrument, not a human eye. But it didn't stop. By 1972, the ground beneath the town of Pozzuoli had climbed by roughly 1.75 meters since the crisis began. And it wasn't just standing there and swelling silently. Starting in February of 1970, the earth underneath the town began shaking. Not one dramatic event, but thousands of them. Small tremors stacking up week after week, all of them modest in size individually. None topping magnitude 2, but nearly 2,600 of them recorded between February and October of that year alone. Picture what that actually feels like to live through. Not one earthquake you brace for, and then it's over. A town where the ground won't stop faintly trembling for months, where every single day brings another few dozen small shocks, none big enough to be the one everyone's bracing for, but the sheer number of them wearing down anyone's ability to believe the ground has settled. By March 3rd of 1970, officials made the call that no government makes lightly. They began evacuating Rione Terra, the old historic quarter of Pozzuoli, the oldest part of the town, built on the highest and most exposed ground. People who had lived their whole lives in that quarter, whose families had lived there for generations, packed up and left a neighborhood that had stood more or less unbothered since Roman times. The ground kept rising through the rest of that year, then began slowly to sink back down again, the way it had for the columns centuries earlier. A crisis, but not an eruption. The mountain didn't build itself a second time. The town got its evacuated quarter back eventually, and the whole event settled into memory as something the region had survived. It happened again 12 years later, 1982 into 1984. And this time, it was worse. Another surge of uplift on top of ground that had barely finished resettling from the last one. Roughly another 1.75 meters added to what the region had already risen since the crisis began, bringing the cumulative total across both episodes to somewhere in the range of 3.5 meters of ground lift in barely over a decade. And the shaking that came with it wasn't in the thousands this time. It was over 16,000 recorded earthquakes, including 2 that reached magnitude 4, strong enough this time to crack plaster, split walls, damage buildings outright. Those 2 quakes in September and October of 1983 stood as the strongest this crisis had produced for the next 40 years. This time, evacuation wasn't temporary. Part of Pozzuoli's population, commonly cited as somewhere around 40,000 people, though I'll be honest that the precise headcount is harder to pin to a single confirmed source than you'd expect for a number repeated this often, was permanently rehoused, not moved out and back. Moved for good into a newly built district called Monte Nuovo, purpose-constructed to take in people whose homes sat on ground the authorities no longer trusted. Think about what that means for a town, not a single house lost to a single storm. A working decision made by people with the authority to make it that an entire section of a community could no longer safely live on the ground its ancestors had lived on for 2,000 years, not because the ground had erupted, but because it had simply moved too much, too fast, too many times in too short a stretch of years for anyone to keep betting lives on it staying still. And then, again, it stopped. The ground eased back down. Pozzuoli and the towns around it absorbed the loss of a neighborhood and went back to something like normal life, the buildings around Monte Nuovo slowly filling in, the Rione Terra quarter slowly reoccupied, the memory of 1970 and 1983 settling into the kind of local history that gets mentioned at dinner tables more than in headlines. Until 2005. That's when the ground started rising again. And this time, unlike 1970, unlike 1983, it never went back down. Not fully, not for good. It has been rising, with pauses and slowdowns, but no real reversal for 2 decades now, right up through the year you're watching this. By the end of 2023, the ground had climbed roughly 1.19 meters since that crisis restarted. By the end of August 2024, it had reached about 1.32.5 meters. And by the end of March of this current year, the most recent figure on record puts it at roughly 1.63.5 meters, with more than 25 of those centimeters added since January of last year alone. The pace, if anything, is picking up, not slowing down. Somewhere in December of 2012, the exact day isn't recorded in the sources I could find, only the month and year, Italian civil protection authorities raised the official alert level for Campi Flegrei from green to yellow. The label they use is Attenzione. Attention, it is not an evacuation order. It is not a prediction of eruption. It's a formal acknowledgement that the ground underneath 500,000 people needs to be watched more closely than ground usually gets watched. That yellow alert has not been lowered since. It's still where it sits today, more than a decade later. And unlike 1970, unlike 1983, this current episode has come with earthquakes that are no longer staying in the background of the story. They're becoming the story. Late September of 2023, a swarm of tremors began, cracking plaster and damaging buildings in the neighborhoods of Agnano and Pozzuoli, badly enough that many residents chose to spend the night outdoors rather than go back inside. In May of last year, an earthquake measuring roughly magnitude 4.4 struck near a crater called Solfatara, a place tourists visit specifically because its ground steams and hisses, a literal open vent into whatever's happening below. Then, in March of this year, at 25 minutes past 1 in the morning, an earthquake measuring magnitude 4.6 struck near Pozzuoli and the nearby town of Boccoli at a depth of roughly 2 kilometers. It knocked debris loose from a bell tower in the Bagnoli district. It injured one person, and 3 months later, on June 30th, at 17 minutes to 1 in the afternoon, another earthquake, also measuring magnitude 4.6, this one near Boccoli, about 5 kilometers down, hit hard enough to trigger a rock collapse on a small offshore islet. The scientists who monitor this ground and the press who cover it both used the same phrase for that one: the strongest earthquake this area had produced in roughly 40 years. Not since 1983. More followed. Magnitude 4 events in July and September of last year. A caldera that had gone quiet, relatively speaking, for 2 decades between crises, is now producing earthquakes strong enough to genuinely damage buildings on what's starting to look like a yearly rhythm rather than a once-a-generation one. Here's where I have to ask you to hold 2 facts in your head at the same time, because this is the part almost nobody explains clearly, and it's the actual hinge this whole story turns on. Fact 1. None of this, not the rising ground, not the thousands of small earthquakes, not even the magnitude 4.6 events, means an eruption is coming, or is even likely soon. Italy's own Volcanological Institute, the INGV, has said this plainly and on the record. The most probable scenario, if this caldera does eventually erupt, is a small eruption, something on the scale of Monte Nuovo in 1538. Not the caldera-forming catastrophe from 39,000 years ago, not the one from 15,000 years ago. Something survivable, something localized, something nothing like the deep past. There's no evidence of the volume of fresh magma a truly catastrophic eruption would require, and the kind of eruption that size tends to announce itself with much clearer warning signs long before it happens. Fact 2, and this is the one that made me actually sit up when I found it, because it complicates fact 1 in a way I wasn't expecting. In 2023, Christopher Kilburn and his colleagues published a piece of research that didn't ask whether magma was rising underneath Campi Flegrei. It asked a completely different question. What is happening to the rock itself, mechanically, after 50-plus years of being repeatedly stretched, cracked, and never quite allowed to fully heal? Think of a car door that's been dented once. Bang it out and it looks fine again, but it was never quite as strong as it was before the first dent. Bang it a second time in roughly the same spot, and it gives way more easily than it did the first time, even if the second impact is gentler than the first. The metal remembers the first dent, even after you can't see it anymore. Kilburn's team modeled the caldera's crust the same way, not as a static container that's either safe or full, but as a material that fatigues. Every crisis, 1970, 1983, and now this one running since 2005, doesn't just come and go. It leaves the rock underneath Campi Flegrei a little weaker than it found it. And what Kilburn's research found, when they measured it, was that the rock's current tensile strength, its actual capacity to resist tearing apart, sits at roughly a third of what it was back in 1984, at the peak of the last major crisis. One of his co-authors put the implication plainly in the university's own release on the finding. The caldera might rupture, even though the forces currently pulling at it are smaller than the forces it withstood 40 years ago. Not because the push from below has gotten stronger, because the ground pushing back has gotten weaker. And Kilburn was careful. This is important, and I don't want to lose it in the drama of the finding. Kilburn himself said on the record that this does not mean an eruption is guaranteed. His research isn't a countdown clock. It's not telling you when. What it's telling you is something quieter and, in a way, stranger. That nothing has erupted yet and everything is fine are not actually the same statement. The ground can survive every single crisis and still be closer to a breaking point than it was the last time, because breaking points, it turns out, aren't fixed. They move, they erode. A little more with every episode that doesn't quite finish healing before the next one starts. So if the ground is genuinely weakening, genuinely closer to some kind of rupture than it's been in 40 years, the obvious next question is, rupture caused by what exactly? What's actually pushing up from below? And this is the part I told you I'd come back to. Rising ground looks from the surface, almost identical whether it's being pushed up by molten rock physically forcing its way toward the surface, or by hot fluids and gas released from a magma body sitting much deeper down, working their way into a layer of hot water-saturated rock a couple of kilometers beneath the caldera and inflating it, like injecting air into a cushion without any actual magma moving upward at all. Two very different processes. Two very different implications for what happens next. And from where we stand, on the surface, watching the ground rise, they can look almost the same. This is not a minor technical footnote. This is the central open question in the entire field studying this caldera, and two serious groups of scientists working from the same public record of the same instruments have reached different answers. An Italian geochemist named Giovanni Chiodini has spent years building the case for the second explanation. Chiodini's approach isn't to watch the ground directly, it's to read the gas. Fumaroles across the caldera, vents where volcanic steam and gas escape straight out of the earth, carry a chemical signature that changes depending on what's happening underground. And Chiodini's published research argues that the pattern in that gas is consistent with pulses of gas and heat being injected from a deep magma body into the hydrothermal system above it, without fresh magma itself migrating upward. In his reading, this caldera could keep behaving exactly the way it's behaving now, rising and shaking for a long stretch of time yet, without that motion ever needing to become an eruption at all. Then, in 2024, a separate team published research reaching, in effect, the opposite conclusion. Working from precise satellite and ground-based measurements of the caldera's shape, combined with analysis of the rock itself, they argued the current unrest is genuinely magma-driven, that real molten rock, on the order of 0.06 to 0.22 of a cubic kilometer of it, has been rising from a depth of 8 kilometers or more beneath the caldera. Not gas alone, the actual material. Same caldera, same public instruments, same years of data. Two different currently published, currently unresolved answers as to what is physically happening underneath the ground that 500,000 people live on top of. I want you to really sit with how unusual that is. This isn't a case of amateur speculation running ahead of the science. These are credentialed researchers publishing in serious journals, using the caldera that has arguably more monitoring equipment trained on it than any other volcanic system on the planet. Seismometers, GPS stations, gas sensors, satellite radar, decades of continuous ground deformation records, and they still can't agree, from the surface, on whether what's rising underneath Naples is rock or gas. It's a bit like two doctors looking at the exact same X-ray and coming back with two different diagnoses, not because either one is being careless, because the image itself, at the resolution we currently have it, genuinely supports more than one honest reading. The rock lets some of the truth reach the surface and buries the rest at a depth no instrument yet built can cleanly resolve. And that's the sentence I want to leave sitting in the air for a moment, because it's the real shape of this story. It's not that nobody's watching Campi Flegrei closely enough, it's that Campi Flegrei is being watched as closely as our current science knows how to watch anything, and the ground still keeps part of the answer to itself. There's a word people reach for, almost automatically, once they hear a story like this one. Overdue. As if a volcano keeps a calendar, as if enough time has passed since the last eruption that the next one is somehow owed. It isn't a word any careful volcanologist uses about a system like this, and it's worth understanding exactly why, because it clears up a misunderstanding that shapes how most people picture volcanic risk in general. The United States Geological Survey has addressed this directly about a different famous volcanic system, Yellowstone, and the logic applies here just as cleanly. Volcanoes are not machines running on a schedule. They don't erupt because a certain number of years has elapsed since the last one. They erupt when physical conditions underground, pressure, the presence and volume of molten rock, the strength of the surrounding crust, actually align to make an eruption possible. Time on its own does nothing. It's not the ticking part of the story. What Kilburn's research actually gives you isn't a due date. It's a measure of readiness, how close the rock is, structurally, to a threshold, regardless of how many years the calendar says have passed since 1984. A caldera can sit past when a schedule might predict something and simply not be ready. Or it can be nowhere near a calendar milestone and cross a threshold anyway, because the crust underneath it happened to fatigue faster than expected. The clock was never the mechanism, the stress was. And there's one more distinction worth being precise about, because it's easy to blur and it matters. Italy's civil protection authorities plan around a specific reference scenario, a medium-scale eruption, roughly comparable in size to one that happened at a crater called Astroni around 4,000 years ago. That is not a prediction. It's a safety margin, a deliberately conservative planning benchmark, chosen so that evacuation routes and emergency response are built for something larger than the most likely outcome, not sized down to match it. The most probable outcome, according to INGV's own public statements, remains that smaller Monte Nuovo style event if anything happens at all. Two different numbers, doing two different jobs. One is a forecast, the other is a margin of caution, and collapsing them into the same sentence is where a lot of the loudest headlines about this place go wrong. Because here's where this stops being a story about one caldera in southern Italy and starts being a story about something much bigger than Naples. Go back to that dented car door for a second, not to re-explain it, but to notice where else you've just watched the same shape appear. The columns in Pozzuoli carry it on a scale of 2,000 years, sink, hold, rise, and the stone that remembers exactly how high the water once reached. The seismic record carries it on a scale of decades. 1970 didn't fully heal before 1983 built on top of it. 1983 didn't fully heal before 2005 started building on top of that. The ground today is still, right now, adding to a debt of stress that has never once been paid down to zero since the moment modern instruments started keeping score. And the rock itself carries it, on a scale you can't see with your eyes at all, only measure, a crust with a tensile strength quietly worn down to a third of what it was, one crisis compounding the last, the way a bruise that never quite fades gets struck again in the same spot, and again, until the tissue underneath simply isn't what it used to be. Three completely different timescales, 2,000 years, 50 years, and a property of the rock itself that doesn't show up on any clock at all. And underneath all three, the exact same signature. Stress that accumulates and never fully resets, not a bomb with a fuse burning down to zero. A system that keeps almost healing and never quite finishing the job, and calling that quiet in between. Think for a second about every other subject this channel has ever pulled you into. A species gone extinct millions of years before anyone existed to watch it happen. An eruption already finished, its ash already settled into a layer of rock somebody dug up centuries later. A discovery already closed, already sitting quietly in a textbook, waiting for you to read about it after the fact. This one isn't that. This one is still open. The seismometers recording Campi Flegrei's ground motion are running underneath Pozzuoli right now tonight while you listen to this. Somewhere on that stretch of coastline, the ground moved today, some fraction of a millimeter maybe, nothing a human foot could ever register, and instruments built by people with decades of training logged it anyway, added it to a column of numbers that stretches back to 2005, and will move again tomorrow and the day after that, whether or not anyone happens to be watching. And underneath 500,000 completely ordinary lives, people getting groceries, dropping kids at school, arguing about nothing over dinner, entirely unaware that their kitchen floor sits on ground, currently 1.5 meters higher than it was 20 years ago. Two of the best resourced teams of scientists studying any volcanic system on Earth are still working from the same evidence toward two different conclusions about what that motion actually means. That's the detail I can't shake. It isn't that we don't know enough about this place. It's that we know an extraordinary amount about it, more, arguably, than about any other caldera on the planet, and the honest conclusion of all that knowledge is a shrug dressed up in decimal points. We have gotten measurement down to the millimeter. We have not gotten understanding much past an educated, competing, sincerely argued guess. There's something almost uncomfortable about sitting with that, if you actually let yourself. We like to believe that watching closely enough is the same thing as understanding. That if you put enough sensors on something, log enough data points, run enough models, the truth eventually surfaces on its own, the way a photograph develops if you just leave it in the right chemical long enough. Campi Flegrei is the counterexample. It is arguably the most closely observed volcanic system on the face of the Earth, and the honest answer to what is happening beneath it is still, today, we are not sure. But here's what we're each inclined to think. And maybe that's worth turning over in your own life for a second, away from the volcano entirely. How much of what you consider settled, decided, closed, filed away is actually just heavily observed, watched closely, logged carefully, and still, underneath all that attention, genuinely unresolved? We tend to treat data and certainty as the same thing. Campi Flegrei is a quiet argument that they're not. You can measure something every single day for 20 years and still not know, with your hand on your heart, what it's actually going to do. The ground under Naples doesn't know either, in any way we could ask it to explain. It is simply doing what caldera floors do, rising, easing, cracking, healing partway, rising again, the way it has for tens of thousands of years, indifferent to whether the creatures currently living on top of it have worked out the mechanism yet. It rose for the mollusks that drilled into marble columns 2,000 years ago. It will keep rising or stop or something in between, on a time scale that answers to physics, not to anyone's need for a clear answer by the end of a video. There's an image I keep coming back to, turning this over the past few weeks. A seismograph is a machine built to listen, not to understand. Every tremor, every millimeter of lift, every gas pulse out of a fumarole gets recorded faithfully, translated into a line on a graph or a number in a database, with total precision and zero interpretation. The instrument doesn't know what it's hearing. It just knows how to write it down accurately. The understanding part, the "what does this mean" part, still has to happen afterward in a human mind, filtered through years of training and, inevitably, through whichever theory that particular scientist has spent their career building. Which means, in a strange way, that the machines watching Campi Flegrei are fluent in a language they only half speak. They can transcribe every syllable the ground produces perfectly, in real time, and still not be able to tell you, with confidence, what the sentence means. Chiodini reads gas chemistry and hears one story. The 2024 team reads satellite deformation and rock samples and hears another. Kilburn reads decades of stress and hears a third story entirely, not about what's rising, but about how much weaker the walls holding it back have become. 3 fluent readings of the same transcript and no consensus translation yet. I don't think that's a failure of science. If anything, it's closer to the opposite. It's what honest science looks like when it's actually at the edge of what current instruments can resolve, rather than pretending to know more than the data supports. The temptation, with a story like this one, is to reach for the version with a clean answer, because a clean answer is satisfying and a genuine unresolved debate is not. But the unresolved version is the true one. And there's something almost more unsettling about that than a countdown would be. A countdown, at least, has an ending you could brace for. This has no countdown, just a caldera, breathing, watched by more instruments than almost anywhere else on the planet, still keeping its own mechanism to itself. There's a crater inside this caldera called Solfatara, a shallow ash-gray bowl of a place, its floor cracked open in spots where boiling mud bubbles up, and the whole basin smells faintly of rotten eggs, because it's constantly venting hydrogen sulfide straight out of the earth. For centuries, it's been treated less as a hazard and more as a curiosity, a place tourists could walk right up to, look into, breathe the strange air of, and leave with a good story and a photograph. A fumarole field, technically, a cluster of vents releasing volcanic steam and gas straight out of the ground, without any lava, without any dramatic eruption, just the caldera exhaling. On September 12, 2017, a family visiting Solfatara walked into that crater and didn't all walk back out. 3 people died there that day. Later, medical investigation attributed their deaths to poisoning from the gases venting out of the ground itself, hydrogen sulfide and carbon dioxide, invisible and in the wrong concentration, in the wrong pocket of still air, lethal within minutes. There's a detail in the record I have to flag honestly rather than resolve, because different accounts genuinely disagree on it, whether the family had strayed off the marked, monitored path, or whether the ground that gave way and released that fatal pocket of gas was on the path tourists were told was safe. I won't pretend to know which version is true, because the sources I could check don't agree, and I'd rather tell you it's disputed than hand you a false certainty either way. What isn't disputed is what it proves about this caldera in miniature. You don't need a magnitude 4 earthquake or 1.5 meters of accumulated uplift or a century of crisis for Campi Flegrei to hurt someone. You need an ordinary afternoon, an ordinary crater that's been a tourist stop for generations, and a pocket of gas nobody could see coming, released by a system that never fully sleeps, even on the calmest, quietest days between crises. The big, dramatic version of this danger, the eruption, the evacuation, the cone rising out of a field in a week, is the version that makes headlines. The quiet version, the invisible gas seeping out of ground, people are standing on right now, killed 3 people on a day when nothing about the seismographs was making news at all. That's worth sitting with, because it reframes something. This caldera isn't dangerous only in the scenario where scientists finally agree on what's rising underneath it. It's already, quietly, actively dangerous in the ordinary sense, on ordinary days, the way any place that vents lethal gas out of open ground is dangerous, independent of the larger unresolved question about eruption risk that's been the spine of everything else in this story. Now go back to that pressure cooker for a second, because I want to give you the physical picture underneath the magma versus hydrothermal debate, not just the disagreement itself. Picture 2 sealed pots on the same stove. In the first, the seal is tight and steam builds up inside with nowhere to go, pressure climbing steadily until something gives: the lid, a valve, the pot itself. In the second, the seal has a slow, steady leak. Steam is constantly escaping, hissing quietly out through some crack in the rim, and because it's escaping, pressure never fully builds toward the breaking point. Same heat underneath both pots. Completely different outcome, depending on nothing but whether the pressure has somewhere to go. That's roughly the shape of the argument Chiodini's gas chemistry research is making about the hydrothermal side of this debate, that the caldera is closer to the second pot than the first. That gas and heat rising from a deep magma body are finding their way up through a 2-kilometer deep layer of superheated, water-saturated rock and venting outward through fumaroles like Solfatara, through the ground itself, in a way that relieves some of the pressure as it builds, rather than letting it accumulate unchecked toward a rupture. In this reading, the ground rises because that layer of rock is inflating, like a sponge soaking up hot fluid, not because a fresh body of molten rock is pushing up from below looking for a way out. The competing 2024 research is describing something closer to the first pot, pressure with less of an outlet, building because actual magma, not just gas and heat, is working its way upward from depth, not a slow, hissing leak keeping things stable, a genuine accumulation inching toward wherever its own breaking point happens to sit. Here's what makes this genuinely hard, and I don't think enough coverage of this place says it plainly. Both processes can leave nearly the same fingerprint on the instruments we have. Both push the ground up. Both can trigger swarms of small earthquakes as rock shifts and cracks to accommodate whatever's expanding beneath it. Both can show up as changing gas chemistry at the surface because heat and pressure from either source will alter what's venting out of a fumarole like Solfatara, whether or not actual molten rock is anywhere near the surface. The signal each process leaves on the surface from 20 kilometers above in a satellite or from a seismometer a few kilometers from the crater floor overlaps so heavily that it takes years of accumulated data and a considerable amount of scientific judgment just to argue for one interpretation over the other. And even then, as we've seen, two serious teams can look at that same accumulated data and land on opposite sides. Now think about what that uncertainty actually means for a person deciding whether to buy a house in Pozzuoli. Not an abstract question of geology, a real practical one made by real families right now in a housing market that exists on top of an active yellow alert zone. Property in this region carries a kind of discount baked into it that property elsewhere doesn't. A shadow price attached to living inside a designated volcanic risk zone. Insurance, where it's available at all for certain kinds of coverage, reflects it. Emergency planning documents divide the area into zones ranked by risk. Evacuation routes are drawn and redrawn. Drills are run periodically for a population in the hundreds of thousands, all of it built around a hazard that the people funding and running those drills will tell you, honestly, they cannot fully characterize yet. That's an unusual thing to ask a bureaucracy to do. Plan seriously, spend real money, draw real evacuation maps for a threat whose actual mechanism remains a live scientific dispute. But that's exactly the position Italian civil protection authorities are in and have been in, arguably, since 1970. You don't get to wait for scientific consensus before deciding how many buses a town needs on standby. The planning has to proceed under uncertainty because the alternative, waiting until the magma versus hydrothermal question is finally settled, could mean waiting through an actual crisis with no plan in place at all. Picture what the actual watching looks like, physically, on the ground, because it's easy to say more instruments than anywhere else on Earth and let that stay an abstraction. Scattered across those 12 or 13 kilometers of caldera are permanent stations, quietly logging position with a precision fine enough to catch ground movement measured in single millimeters, day after day, uploading automatically, feeding into control rooms where someone is at every hour watching a screen. Above it, satellites pass over on a fixed schedule, bouncing radar signals off the ground and comparing each pass to the last, building up a picture of the entire caldera's surface rising or settling, not just at one point, but across the whole basin at once, like watching a very slow tide come in from orbit. Underground, seismometers sit, listening for the faintest tremor, calibrated sensitive enough to register the small, sub-magnitude 2 shaking that would have gone completely unnoticed by anyone standing above it. And every one of those tiny events gets a timestamp, a depth, a location, added to a database that by now stretches back decades. And at the fumaroles, instruments sample the gas itself continuously, tracking the shifting ratios of one compound to another the way a physician tracks blood work, looking for the kind of chemical signature that might, eventually, tip the argument one way or the other. All of that, running continuously, has been running for decades, and it still lands two serious research groups in different places, which tells you something about the actual limits of watching, not the effort behind it. Nobody involved in monitoring this caldera is being careless or under-resourced or slow. If anything, they may be running up against the ceiling of what surface observation alone can tell you about a system that's doing most of its work several kilometers beneath the reach of any instrument we can currently put down there. Now, bring that back to ground level, to an ordinary Tuesday in Pozzuoli. Somewhere in that town, a family is deciding whether to fix a hairline crack that appeared in a wall after last year's magnitude 4.6 event, weighing whether it's cosmetic or something to actually worry about, the way anyone weighs a crack in their own house, except this family also knows, because everyone there knows, that the ground under that wall has risen more than 1.5 meters since 2005. And the last two comparable stretches of ground rise in this exact town ended with a neighborhood being evacuated. Somewhere else, a shopkeeper is deciding whether the noticeably increased seismic activity of the past 2 years is worth planning around, or whether it's simply what living here has always meant. As for anyone under about 60, the last major crisis in 1983 isn't a lived memory so much as a story parents and grandparents tell. That's the strange psychological weight of living inside a system like this one. Not constant fear. Nobody could sustain that for 2 decades over an ordinary daily life of groceries and school runs and dinner. Something closer to a background hum of awareness that never quite resolves into either "this is fine" or "this is an emergency." Because the scientists themselves, with every instrument available to modern science trained on the exact ground under that family's kitchen floor, haven't resolved it either. You learn to live inside a genuinely unanswered question. Most people, most places, don't have to build an entire daily life around one. There are 4 levels in that alert system altogether: green, yellow, orange, red. And it's worth understanding what separates them, because most people who've heard yellow alert for years assume it sits closer to red than it actually does. Green is the baseline ordinary state. Yellow, where Campi Flegrei has sat since that end of 2012, means heightened monitoring and increased public information. Official acknowledgement that this ground deserves closer attention than normal, nothing more. Orange would mean the signs have escalated to where an eruption is considered possible in a matter of weeks, the point where evacuation planning moves from paper into active preparation. Red is reserved for imminent or already beginning eruption, the level at which evacuation itself is actually carried out. 14 years of yellow is 14 years of watch closely, not 14 years one notch away from catastrophe. The distance between yellow and red isn't a short step. It's the entire rest of the scale. That gap matters for how you should hear everything else in this account. A magnitude 4.6 earthquake, 1.5 meters of accumulated uplift, 16 years of essentially uninterrupted ground rise. All of that has occurred entirely within yellow. None of it has been enough, by the assessment of the people who actually set these thresholds, to move the needle to orange. That's not because those events were minor, it's because the threshold for orange is calibrated to something more specific than concerning, clear geophysical evidence that points toward an eruption on a timescale of weeks, not months or years. Whatever is happening beneath Pozzuoli right now, by the judgment of the agency watching it most closely, hasn't yet produced that specific signature, even after 2 decades of essentially continuous uplift and a recent run of the strongest earthquakes the region has produced since the 1980s. Sit with that, because it's the detail that makes this whole story so hard to file away as either nothing to see here or the big one is coming. A system can climb, crack, tremble, injure people, damage buildings, produce research findings about crustal weakening serious enough to publish in a major journal, and still, by every formal measure currently in place, be sitting at the second rung of a 4-rung ladder. Not because the danger is being downplayed, because the actual threshold for real, imminent danger, as currently defined, is calibrated to something even more specific and more severe than everything this caldera has produced so far. And that, more than any single earthquake or any single meter of uplift, is the real measure of how strange this place is. It has done enough, over the last 20 years, to reshape how scientists model volcanic hazard, to force new research into how rock fatigues, to keep an entire civil protection apparatus on permanent alert footing for a generation. And it has still not done enough, by the caldera's own official scale, to move past the second step. Take a breath. Feel your chest rise and settle again, and rise. That's all Bradyseism ever was at its simplest. The ground doing on a scale of centuries, the one thing your own body does without thinking, every few seconds for an entire lifetime. Go back to those 3 columns, standing in their plaza, marked with a tide line, no tide put there. They're not a monument to a disaster. Nothing collapsed, nothing was destroyed. They're a monument to something quieter and, I think, stranger. Proof that the ground can move enough to submerge a temple, hold it there long enough for the sea itself to leave a signature in the stone and give it back, and the building simply keeps standing through all of it, patient in a way nothing alive could ever manage to be. That's what's happening under Naples right now. While you finish listening to this, not a countdown, not a fuse, a caldera breathing the way it has for tens of thousands of years, watched more closely than almost anywhere else on Earth by people who can tell you the millimeter and still can't tell you the meaning. Maybe that's the most honest place a story like this can end. Not with an answer. With the ground still moving and the best instruments we've ever built still listening, and still, patiently, half a world away from understanding what it's trying to say.